Welcome to Simple Programming channel. I hope you are all doing well. I haven't been uploading any content for a long time due to some issues, but now I'm back. Before we start a new lesson, don't forget to subscribe if you are new here on my channel and turn the notification button on so that you get updated whenever I upload something new. So let's get started now. In the previous videos we have seen how to declare a variable. We handle an integer data type. We have seen how to declare an integer variable and how to assign a variable to it or a value to it, and we have also seen how to set an input by the user. Today we will talk about the other existing data types in Java language. Okay, let's create a new project first. I think you are familiar with that. File, new project. Here we have click next, then the project name, let's give it name Java data types. And check the create main class and then finish. And here is our project created. Let's go to source packages, new Java class. Let's call it data types or data type. Click on finish. Okay, here is our class, public class data type. As we have said before, we write the code between these two braces. Okay, let's first create our main method as we saw before. Public static void main string args, open brace and closing brace here. Okay, let's now talk about the data types, then we go back to the code. In Java we have 8 primitive data types, which are byte, short, int, long, float, double, boolean, char. Now, what is the difference between these data types? The difference is in the size and also the type of variables that we would like to store in them. For example, for the byte data type, we can store whole numbers like 1, 2, 3, 100 from -128 to 127. You have to keep in mind that 1 byte contains 8 bits. So what is a byte? Here is 1 byte that contains 8 bits or 8 cells, and you know guys, the computer doesn't understand the human language. For example, when we type number 2, Java understands it as 10 because the compiler will convert our language or human language to the binary system that the computer understands. Now, for each character or number we have a binary representation. And for example, the representation of number 1 in binary system is 1. The representation of 2 in binary system is 10. Representation of 3 is 11. The representation of 4 in binary system is 100, and so on and so forth. So that's the logic behind how you can store numbers according to their data type. Now, as we have said, the byte data type can store only numbers from -128 to 127. What does it mean? If we declare a variable of byte data type and we assign it a number out of this range here, the compiler will give you an error. Let's check that in the code. Let's create a byte data type. Byte x is equal to -128. Now the compiler doesn't give any error, everything is okay. So let's suppose that we give a number that is out of the range according to the definition. Let's say minus 129, sorry. And here there is an error that appears in the left side here. Let's see the type of the error. Here it tells you cast minus 129 to a byte. That's not what we want because we haven't seen how to cast numbers yet. Now in the second suggestion it tells you change the type of x to int. Why it says that? Because int is larger than byte, and here minus 129 is oversized. If we want to store minus 129, we just need to change the data type to short. As you can see here, we have no error or just integer. So I hope you understand this matter. Now you have to know that byte, short, int, long store whole numbers like 1, 100, 12, 65, in general numbers without comma. Now we have float and double. These float and double data types store fractional numbers. That means numbers that contain comma or they have a decimal part. And the difference between float and double is that the float can represent a decimal part up to 7 digits of precision. For example, 154, comma 1111118. We have 6 or 7 digits after the comma. When it comes to double now, double can represent the decimal part up to 16 digits of precision. As an example, we have 25, comma 12, 12, 12, 12, 12, 12, 12. 8 times 12, that means 16 digits. For the boolean data type, its size is 1 bit. That means it can store 1 or 0, and the 1 corresponds to true and 0 corresponds to false. Char or char data type stores a single character like A, B, C, D, and so on and so forth. So that's everything about primitive data types. Now, when it comes to non-primitive data types, I don't think we have enough knowledge to talk about it right now. But all what you need to keep in mind is that the string data type is non-primitive, but it's used like a primitive data type. Now let's code and give an example about each data type we have learned today.